number 1 and 2. So in number 1 there they are saying 10 balls numbered 1 to 10 are placed in a bag and one is chosen at random. And one is chosen at random. And then number 8 they are saying use the letter O to represent the event of getting an odd number and represent it in a inset notation. So I believe that was not difficult. We're going to use letter O. So we're going to say number A, letter O is equals to our set builder notation. It's what the numbers are numbered from 1 to 10, but we're looking for what? For odd numbers. Can you give me those odd numbers? Okay, let's check there. What did you write? 1, 3. I can see here. It's 1, 3, 1, 3, 5, 1, 3, 5, 7, 9. That's correct. 1, 3, 5, 7, 9. Then we close the bracket. Then this is 1 mark. It's correct. Let's reduce here. Okay. Then let's go to the next question. This was number A. The next question, that's our set. Use the letter what? E to represent the event of getting an even number and put it in a set notation. So E, that's number B. Let's go to number B. E is equals to, that's correct. There it is. It's correct there. 2, 4, 6, 8, 10. That's correct. And then number C, draw a Venn diagram to represent the sample space S and the above events. A Venn diagram to represent the above. Okay. We don't have anything in common between the two, and our sample space is the numbers 1, 2, 3 up to 10. So you are supposed to check list to indicate this is event O and this is event E. Then you will get all the marks. I believe 1, 2, 3. 3 marks can do. So you're supposed to indicate this is event O, this is event what? E. Is that okay? Yeah. Then let's do number D. Determine the probability of getting an even number. The probability of getting an even number. Let's see. No. Yes, your answer it's there, but no. No, 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 no. You are supposed to do it like this. The formula must be there. You don't just write the answer. No. P of E, that's an even number, is equals to how many even numbers are there? 1, 2, 3, 4, 5. It's 5. 5 over what? How many numbers are there? There are 10, Yes, you're supposed to do it like this. Don't just write the answer. The probability of getting an even number, then the probability of getting an odd number, I think the answer is still the same. This was number what? This was number D. Then we're going to number E. Tell me the probability of getting an odd number. Let's say we get an odd number. Still the same. It's O for odd number. P of O equals to how many odd numbers are there? 1, 2, 3, 4, 5. There are 5. And then in a sample space, how many numbers do we have? We have 10 numbers, That's over 10. The answer is 1 over 2. Yes, or 0.5. Okay. Now, number F are events O and E mutually exclusive. Justify your answer. Let's see how you said it. Yes, because there is a 50% chance of getting an even number or odd number. Okay, your answer for yes, it's correct, but your justification was supposed to say because they cannot happen at the same time. Because they cannot happen at the same time. Okay. Then number G there, now they twist the hand. There are events O and E complementary events. Justify your answer. Are they complementary events? Okay, you don't know what you don't know what is the complementary events. A complementary event, it's like this. If I don't happen, you are happening. If this one it's not happening, that other one is happening. Yes, like a head and a tail. So a head and a tail, it's a complementary. When you flip a coin or when you run an experiment of flipping a coin, getting a head or getting a tail, we call those two events complementary events. Because if the other one is not happening, the other one is happening. So it's in short, if you didn't get a tail, it means you got a head. If you didn't get a head, it means you got a tail. Yeah, so we must agree. So in short, when you run an experiment, the conditions of the experiment need to be stated out. That the coin is a fair coin, the coin has two sides only, it's a head or a tail. Those things need to be stated out. So here, a coin or flipping a coin, it's one of the what we call complementary events. They complement each other. So the answer here are events O and E complementary events. I think the answer is yes. If you don't get an odd number, you will get a what? An even number. So it means these two are complementary events. The answer will be yes. Then if they say justify your answer, what would you say? If I don't get if I don't get a tail, if I don't get a what an even number, I get an what an odd number. It means the other one is happening when the other one is not happening. Yes, that's what we call complementary. They complement each other. Okay. Uh, but please take note, complementary events are not necessarily mutually exclusive. Yes. Oh, let's see here. Number 2. Numbers from 1 to 10 are written on cards and placed face down on a table, and one card is chosen at random. So we have 1 to 10 again. Use the letter A to represent the event of getting number less than 3. So let's go number less than 3 and represent it in a set notation. So this is number 2. Uh, let's have it. Let's have it here. Number 2. Okay, it's fine. Can we go back here and remove this? It's fine. Let's remove this. And then we start number 2 quick. Start number 2. Yes. So I want to see your sample space. Okay. Oh, okay. Let me try to reduce this. Thank you. Can you still see? Okay. So number 2, they are saying use the letter A to represent the event of getting a number less than 3 and represent it in a set notation. So it's going to be A is equals to 1 and 2. The numbers less than what? Less than 3. That was number A. Then number B. Use the letter B to represent the event of getting a number greater than 7 and represent it in set notation. So we have B here is equals to number greater than what? 7, 8, 9, and 10. Then let's check your answers. 1 mark for each. 8, 9, 10. Your brackets, they are not nice. No, no, no. You don't use the normal. Every bracket says a lot, so this bracket needs to be changed. They must be like this. We don't use this. So these one are inclusive brackets. Yeah, so you need the bracket. Your bracket must be this way. Number C. Draw a event diagram to represent the sample space S and the above events. Okay, let's see. Ah, they are not happening at the same time. At the same time, you forgot to write this is A, this is B. So they're not happening at the same time. That's good. I think 3 marks can do. Uh, uh, 8, 9, 10. Yes, you're supposed to indicate. Please fix that thing of naming them. So event diagram is there. Determine probability of A. Probability of A. So we are done with this page. Or let's move it down. Don't like it. Ooh, why are you not moving? Okay. Probability of A, there it is, 2 over 10. 2 over 10. That's very good. 2 over 10. This is very correct. There are two items in event A, and then in total we have 10. So this is correct. And then probability of B, 3 over 10. That's correct. That's very correct. I'm happy. And then let's see here. What are they saying? Are events A and B mutually exclusive? Justify your answer. The answer will be yes, because help me there. Now I won't read yours. I want to hear whether you heard me on the previous answer. Because they cannot. Yes, simple as that. Because they cannot happen at the same time, since you are throwing one card at a time. Yeah, so you cannot get a number that is less than 3 and a number that is greater than 7 at the same time, since you are throwing one card at a time. So yes, they are mutually exclusive, but okay, let's go now to number A. Are events A and B complementary events? Is it yes or no? The answer is no, because in this simple space, remember, look, let me go take you back to your Venn diagram. In this sample space, look at your sample space. I want to show you. Okay, now let's start with this one. Exactly this one. I don't know why are you freezing, but it's fine. Okay, looking at this at this sample space of yours, when you draw a card, you can draw a card that is less than 3, or you can draw a card that is greater than 7. You miss the number 3 here. There's no number that is 3. So you can draw a card that is greater than 7. At the same time, you can draw a card that is equals to 4, or a card that is 6, or a card that is 3, or a card that is 7, or a card that is 5. So let's check. If you draw a card that is equals to 4, or a card that is equals to 3, event A is not happening, and event B it's not happening. So are they complementary? Okay. Let's go back to the other one. Here we said yes, they are complementary, because whenever you draw a card, whenever you draw a ball, it's either you're drawing a ball that is in O or a ball that is in what? In E. So it means if event O is not happening, event E is happening. So that's why we say they are complementary, this one. But here, if event OA is not happening, it does not mean that event B is happening. So that's how I say they are not complementary. Yes, do you see the difference now? We are still on probability. We are just wish today we finish. Probability. So the first example, let's get this one. Yes, a grade 11 learner asked 200 people 200 people whether they they like milk or cream in their coffee. In their coffee or tea. In their coffee or tea. So full stop. What did he get, this person? He found that 72 people liked cream. 72 people liked cream. Liked cream. 110 liked 110 liked milk, and 40 liked 40 liked milk and cream. Liked milk and cream. Okay, so here is the question. The first question, before let's go to this way, but okay, we'll have to revisit this statement. We'll have to revisit this statement. Here is the question: how many people liked only cream? Okay, we will check that. Number A, let's go. How many? How many? Many people. How many people liked only cream? So I heard you are saying 72. So here we are saying only. So let's reread. A grade 10 learner asked 200 people. So there are 200 people that this learner is asking whether they liked what? Milk. So we're comparing between milk or cream in their coffee. So milk or cream in their coffee. Come again. No, no, no. Let's read the question, try to understand the question. Let's not do assumptions or predictions. So he found that, let's read that. He found that 72 people liked cream. So it's 72 people that liked cream. But the question is asking about those who liked cream only cream. But here we have 72 people who liked cream. But they didn't say these 72 people they liked only cream. So we need to know how many liked only cream. So let's go again. 110 liked milk. Same statement again. They are not saying this 110 liked milk only. Do you see that? And then let's read here. 40 liked what? Milk and cream. So if we read this statement, we will get that, okay, we have 40 people who likes what? Milk and cream. So these 40 people, some of them might be in this 72, some of them might be in this 110 people. So it means then if we want to know how many people likes only cream, we have to remove 40 people from the 72. Because in these 72 people, we have 40 people who likes what? Milk and cream. Do you see that? Yes. So only cream, number of people who likes only cream, number number of people, number of people, people who likes only cream is equals to, we have 72 people who likes cream, and then we have 40 people who likes what? Cream and milk, or milk and cream. Does it make sense? Okay. So the statement you see here, we are playing with words here. So how many those who likes only cream? How many? Okay, it's 30. I think I made an error. It's 72 here. Then the answer is 32. Okay. Let's go to the next question. So what we are getting into, we need to pay attention to what they are telling us more than just the straightforward ones. And then how many people liked only milk? I believe this one will get it correct. How many people liked only milk? How many liked only milk? 70. I think that's correct. How did you get it? Okay, that's correct. 110 minus 40 and then give you 70. How many people liked only milk? Only milk. So the answer here is going to be uh 110 minus 40 is equals to 70. So this is the number of people who liked only milk. Then let's move to the next question. How many people did not like cream or milk in their coffee? Mhm, 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 mhm. How many people did not like milk or cream in their coffee? Number C. How many? Don't guess. It's dangerous to guess. You took what? Okay. How many people are we talking to here? We're talking 200 people. So it means if you want to know how many didn't like milk or cream, we have to subtract from this 200 the number that we got. We have to subtract the people who liked cream and milk, and those who liked those who liked cream only, and those who like what, milk only. So did you, let me repeat again. If you want to know how many people didn't like milk or cream in their coffee, we have to take the total number of people, which is 200, and then subtract those who likes what, cream and milk, and subtract those who likes milk only, and subtract those who likes what, cream only. Okay, hello. Okay, let's write the question while you're doing your calculations. How many people, how many people did not like cream or milk in their coffee? So what are you getting? 50, 58, Anne? Okay, so this is how we do it. I think that answer is correct. So let's just do the formality. The number of people interviewed, they are 200. The number of people who liked cream and milk, they are 40. The number of people who liked what, cream only, they are 32. The number of people who liked milk only, they are 70. So what is the answer of those who didn't like anything? 58. You are learning something for sure, ne? Then number D, record this on the Venn diagram. Now don't worry, record the above information on the Venn diagram. The above information on a Venn diagram. Record the above information on a Venn diagram. Very straightforwardly so. Let's go. Going to create our Venn diagram. Mhm. Mhm. Let's go. Let's record. And then here is our Venn diagram. Then first thing first we're going to do before we do our presentation of our Venn diagram, we need to check, do we have intersection between milk and coffee? Between milk and cream? Do we have people who likes milk and cream? So it means we have an intersection. These two must touch each other because we do have people who likes cream and milk. So this is going to be C for cream and then M for milk. Is that okay? Then we start with those who likes cream and milk. How many are they? How many are those who likes cream and milk? 40. You see? Then how many are those who likes cream only? The number of cream only this side. 32. And then milk only. 70. And then those who don't like cream or milk, how many are they? They're outside now. Those who don't like cream, those who don't like milk, how many are they? 58. Then when you add these numbers, when you add them together, they must give you the total sample space, which is equals to what? 200. So let's add 58 plus 70 plus 40 plus 32. What you get? 200, isn't it? So which is the total sample space. So we are very much happy. Now let's move to the next question, number E. What is the probability that a person chosen at random will like milk or cream? Will like milk. What is the probability that a person chosen at random will like milk or cream? Let's write it down. Number E. What is the probability? Now we're doing probability now. What is the probability uh, probability that a person chosen at random will like cream or milk? Will like cream or milk? So let's check this statement. I believe this is the statement probability of what? Of C or M. And then according to our formula, if you remember our formula, it says this is equals to what? Probability of what? Probability of what? Of cream only. Is probability of cream only. Probability. Extra. Probability of cream only. Cream only. Close plus probability of milk and cream. Milk and cream plus probability of milk and cream. Milk and cream plus probability of what? Probability of what? Of milk only. M only. Milk only. Then this is equals to what? Probability of cream only, it's 32 over the total. 32 over 200. You see that? Plus probability of milk and cream, it's 40 over the total. Plus probability of milk only is 70. There it is, 70 over 200. There it is. Then you check your calculator, what you get? 71 over 100. That's correct. That's 71%. 71 over 100, which is 0.71. That's correct. Your probability must be between 0 and 1. Remember that, Anne? So if you get this statement, they are saying, what is the probability of getting someone who likes cream or milk? So it's a union. You can like cream, you can like milk, or you can like both. That's why we're adding all the numbers. For cream only, for milk and cream, for milk also. So we are just, it's a union of cream and milk. That's why we're adding all the numbers and then all the probabilities. Is that okay? Now we move to the next question, which is number F. Let's get number F. what is the probability that a person chosen at random will not like either cream or milk? Let's go ahead. What is the probability that a person chosen at random will not like either cream or milk. Will not like either cream or milk. Either cream or milk. Okay, so this person will not like either cream or milk. It means this person does not like both of them. Who is that person? Kiyo, do you see that person? That here's the person. Those who don't like milk or cream, there are how many are they? Yes, that's what we are talking about. See here, we are saying those. What is the probability of choosing a person that does not like either cream or milk? It's those that are not interested in any of these. So they are 58. So divided by 200 is probability. That's what we call probability of not cream or milk. So it's equals to what? It's equals to 58 over 100, which is equals to what? Oh, over 200, not 200. 0.29. There is our probability. And then let's move the next question, the last question on this example. Number G. What is the probability that a person chosen at random will not like cream? What is the probability? Let's read. What is the probability that a person chosen at random will not like cream? So what we are dealing with here, we are dealing with someone who does not like cream at all. So let's see those people who don't like cream. Do you see them? How many are they? Not cream. Yeah. What is the problem that a person that chosen at random will not like cream? So it's not cream. So let's count the number of people who don't like cream. How many are they? Let's look here on the Venn diagram. We have this one. How many? There are 7 who don't like cream, but they like milk. And then we have these 58 who don't like cream. They don't like cream. So all we care about is that they don't like cream. You see that? So let's go there. It means what I'm going to say. We're going to add the two probabilities. It's going to be probability of not milk, not, is it not milk or not cream, honey? It's going to be probability of what? milk only plus probability of what? Of not milk or cream, because we are not looking, the issue here is that you must not like cream. So if you like milk only, it's fine. You see that? If you like milk only, it's fine, because we are not looking to get, we are looking for someone who don't like cream. So if you like milk, it's fine. I- If you don't like milk or cream, you are still okay. So let's see. Milk only, how many are there? It's 7, Jane. 70 over 200. Milk only. Let's see. It's what? 70 over 200. Then we add the probability of not milk or cream, which is 58 over 200. The one that we did earlier. Yes. So what is that you get? This is not milk or cream. So let's add to them together. What do you get? Yes, 0.64. There it's correct. Okay.